Hi friends, in today's class we will discuss shear stress and shear strain. What is the meaning of shear stress and the corresponding shear strain? We know whenever there is a tensile force is acting on a body, tensile stress will develop and the corresponding strain is known as tensile strain. If a body is subjected to compressive force, then compressive stress will develop and corresponding strain is known as compressive strain. Similarly, whenever two equal and opposite tangential forces are acting across a section, that means suppose if it is a body over which another body is there, we are applying two equal and opposite tangential force, this one and this one. These are nothing but tangential force. If we are applying force in this manner, this is nothing but called shear force. What is it called? Shear force. So across this section, the body will shear out. That means it will slide. If one body is over another body and I am applying forces, another force is here, it will shear. It will shear. That means due to this shear force, a resistance will develop. That is nothing but shear stress. Shear stress is nothing but this shear force per shear area. Look at here. So if I am applying force on this object, let initially the point is here. So after application of force, let it will move up to this. It will move up to this. That means the shear area is this one. Let us see. Suppose this is one body, this is another body. I have kept one over another. Okay. So now let's put a line here. Now I am applying force over this. So on pink color object I am applying force, and on green color copy I am applying the force. Now it will shear. So how much shear? This much initially it was here. So after the application of force, it will shear up to this. So this is nothing but shear area. This amount is nothing but shear area. So this tangential force I am applying. This tangential force for this area is known as shear stress, and the corresponding strain is known as shear strain. So we concluded that what is shear stress? That is shear force applied, shear force divided by area. What is that area? Shear area, not cross sectional area. If it is a case of tensile stress or compressive stress, we will divide the cross sectional area. Suppose this is a body, I am applying force here and here, tensile force. So what is tensile stress? Due to this, a resisting force will develop, that is P per cross sectional area. This is nothing but cross sectional area. This force and this area are perpendicular to each other. So this is tensile stress. Similarly, compressive stress also, this is the perpendicular area, cross sectional area. But here, in case of shear stress, we will divide shear area. This is nothing but shear area. This is cross sectional area, and this one is shear area. How much area it will cover after the application of that tangential force? That area will divide. Now come to shear strain. Let us consider a cube. A, B, C, D. Let this is A, this is B, this point C, this is D. Now I am applying, this is fixed in the AD side. Now I am applying a force on BC surface. On BC side I am applying force P. Then due to this P, let the cube distorted to B dash and C to C dash. So after distortion, the cube changes to A, B dash, C dash, D dash. What is shear strain here? That is nothing but deformation per original length. As strain says, change in length by original length. So here deformation is nothing but change in length divided by original length will give strain, shear strain. So let the length of this cube is L. Okay, let this is distorted by an amount I. So what is the deformation? Initially B point is there, now it comes to B dash, C to C dash. So what is the deformation of the C dash or B dash? C dash or B dash divided by what is the original length of the object? L. L is nothing but AB. Now look at this triangle ABB dash. So phi BB dash divided by AB, it will give tan phi. So for very small angle phi, tan phi is equal to phi. Since phi is very small, if phi is very small, we can take tan phi is equal to phi. So phi is nothing but, this is nothing but shear strain. But it will come C dash by original length, C dash or B dash divided by original length. This is nothing but shear strain. In today's class, we have discussed shear stress and shear strain. What is shear stress? This is when a body is subjected to two equal and opposite tangential forces across a section. Then what is shear stress? Now, due to this tangential force, an internal resistance will develop. That resistance is known as shear stress. Or due to this external tangential force, an internal resisting force will develop. That internal resisting shear force divided by shear area is known as shear stress. And what is shear strain? This is nothing but deformation for original length. It is measured in angle phi. Thank you. Thanks for watching this video.